In today's class of operating system, we'll be moving on to the next topic, which is nothing but free space management. Having seen the various file allocation methods, we have understood how you allocate a file onto a disk. But how you keep track of which of the blocks are free so that the file can be dumped onto this list. So we have some techniques to implement this free space management. One is your bitmap, linked list, grouping, counting, and space maps. Coming to the first technique of your free space management, you will be given a set of blocks, and each block will either store a value 0 or a 1. A bit 0 indicates that the block is not free, it already has some data, and a bit 1 indicates that the block is free so that you can use it for storing your data. But bit 0 indicates occupation, it is not free, whereas bit 1 indicates that it is free. Now, based on this particular bit 1 or 0, how do you calculate the block number? So, the calculation for your block number is nothing but number of bits per word. So, when you want to represent a word internally in binary form, how do you represent it? And that depends upon your system. It can be either 32-bit or 64-bit or 8-bit depending upon your operation, multiplied by the number of zero valued words. So if you just see this particular vector or an array, you count the number of blocks which are having a value 0 and offset of the first one bit. So wherever you are having 1, you just need to calculate the offset. So when I take the example here I am having a value 1. So what would be the offset here when I start the block? Offset value 1, 2 and 3. So my offset value would be 3. So based on these values, you will be able to calculate the block number. Let us see with our example here. Here I am taking a word which is of 32-bit length, and these are some words filled with 1 and remaining all with 0. Now if you want to calculate the block number which is free, the number of bits per word is nothing but 32 into number of 0 valued words. So out of all these things, these are being filled. So how many values are filled? 3. So multiplied with 3, 32 into 3 plus. What is the next one? Offset of your first bit. Offset of your first bit is nothing but you try to, these are all empty here. So you try to, these are all empty. You try to identify the offset value. Since we are starting with an index here 0, offset would be ranging from 0, 1, 2 and 3. So the first offset here would be 3. So you write your offset value. You can either take the offset value starting from 0 or you can take it as 1, 2, 3. But in this example, we are taking from 0. So my offset would be 3. So when you write here 3, when you multiply, you get a value. So this indicates your block number, which will help you to identify that this particular block is free. And you can use that particular block for dumping the data which is present on a file. Coming to the advantage of it, it's very simple. Why it is simple? Because you are only checking whether it value is 1 or 0. If it is 1, you try to occupy this particular block by calculating the block number, and it is also very efficient, right? But the problem is you have some hardware features which are not supporting your software functionality. Why? Because when you go for your bit vector again here it happens to be an array, and the problem comes where to store the bit vector. Do I need to store it in a register, or do I need to store it in a main memory, or do I need to store it onto the disk? And as we all know the problems with storing the data onto the register, memory and disk, we finally go for storing it in the main memory. But if it is smaller disk, you can store it. But for larger disk, we need to go for the other alternatives. Coming to the next technique of identifying the free space management would be linked list, where you will have a pointer pointing to the first block that is free. And from that block, you have a pointer pointing to remaining all other blocks which are free. So from this particular starting pointer, if you just know the address of the starting head pointer which is free, you can trace to all the free blocks that are available. So it is very easy. But coming to the disadvantage, searching becomes very difficult. Why? Because you have to move on traversing from one link to other link, and you already know the links pointers. When I'm using pointers, they are not that much reliable. One of the pointers break down, you cannot move on to the next pointer. Coming to the third technique of identifying the free spaces in the blocks available, we go for using a technique known as grouping. Now let us understand this with an example. We have 16 blocks here and all these blocks are free, and the list of these blocks 1 2 7 8 are being allocated. So what we do in this grouping is we go for grouping these free blocks into, now for example, if I decide my block size as 4, so what I do, I'll group it. So 3 4 5 6 will be grouped under one group, 9 10 11 12 will be under other group, group 2, and 13 and 14 would be in another group. So when you see this, when you are showing all these blocks are empty, right? So the first block will contain the address of remaining n minus 1 blocks, or we can go for a situation where the last block will contain the address or the IDs of all the blocks which are free. So in 3 4 5 6, what is your last block? Block 6 will contain the address of the blocks 3 4 5. And here in the second group, the last block is 12, and this 12 will contain the address of 9 10 11. And in this, the last block is 14 and it contains the address of 13. So here you are able to identify how many blocks are free, and the address of each and every block is maintained in your last block. But when one of the block is getting occupied, so you have to change the total list. You need to regroup again. The group has to be made again, and you have to change the total group. So that is the main problem when we go for grouping technique. Coming to the next method of free space management, we have a counting technique. We'll take the same example where the 16 blocks, out of which this 14 are free and these are the remaining blocks which are available, right? Where the block numbers are here and these are free and these are allocated, right? Now here we'll just maintain a block number, the starting block number which is free. Now 3 is free, right? Adjacent to that, how many blocks are free? 4 5 6 are 4 5 6 are free. So what are the total amount blocks that are continuously free? 3 4 5 6 means 4. So you just write the starting block number and the total continuous blocks that are free. So from including 3, so you have to even include 3. That is the reason you get a value 4, 3, 4, 5, 6. And the next contiguous blocks here are nothing but 9, 10, 11, 12 and 14. So you'll just write the starting block number 9 and the remaining blocks till 14 including 9. So you'll get a value as 6. And if they are not contiguous, you will be just writing the starting roll number and that particular block. So here it is fast allocation for contiguous free blocks. Random access is possible and overall list is also small because you just know to load the block number and link it up with the number of blocks that are continuously free. And each free block, if you want to store each free block, so you require an extra space, and whenever you are entering the data into an empty block and deletion, this may take some amount of time. And the last technique which we'll be using in free space management is related to your space map. So when you go for your space map here, you will be having a pool of memory. From the memory, you will be dividing it into blocks, and this blocks we generally call it as meta slab. So this is a name given to the partition, right? And this is generally used in your ZFS, right? Zerabyte file system, where the divided memory, each partition is called as a meta slab. So, and the information about which of them are, and each meta slab can contain the data related to a file. And this file metadata will be stored in a space map. So you are to be very much clear about these three things. One is related to a meta slab, which is nothing but the partition in the available memory, and which partition to select, that will be depending upon your selection algorithm. And we go for using the metadata, the data related to a file, start as starting block, what is the length of it, what is the type of the data you are storing, and for that we go for using a space map. The data related to the file will be stored in a data structure which is known as a space map, and it is stored in log structured format. And the memory available is divided into parts, and each part we call it as a meta slab, where the actual file will be. So in meta slab we actually go for storing the file data. Now coming to the advantage of this here, the advantage here is when you want to maintain huge amount of data, terabytes of data, in that case we generally go for using this particular file system. But the disadvantage is it includes complexity because you even have to maintain a log format structure for your space maps, which is nothing but metadata information has to be maintained, and searching will also become difficult. So this is about the various types of techniques which are used for creating a list of available free spaces so that you can allocate your file data.